All right, now we're going to talk about when dimensions in our data warehouse change. Now, overall, dimensions rarely ever change. Once they're created, they stay the same. But let's take the case where one of your dimensions might be an employee table, right? And inside that employee table, we have some data values. We have the first name, we have their last name, and then let's say that we have their title. So let's say that we have employee number one, and employee number one gets married or gets divorced, or for whatever reason has a change to their last name. Now, we have to make a decision as an organization if an employee changes their last name, if we care to track it or we care not to track it. So if an employee decides to change their name, typically organizations do not care about tracking a name change. So this is what we call a type 1 slowly changing dimension. It's a change the business does not care to track. However, let's say that an employee changes their title. Let's say that they go from a supervisor to possibly a manager. Typically, this comes with more money, and it also shows that they have initiative and they're increasing their value in the organization. And so the organization may decide they want to track this change. So this becomes a type 2 change. All right, so how do we model that? Okay, well, with a type 1, we're just going to replace the old data with new. So in this case, we're going to overwrite the last name, and we don't care if they change their name 100 times. There is no reason to be able to track this. We're going to lose that historical record. So that is nothing more than updating the value in that particular table. However, for each changing attribute, in this case a title, we have to create a field that is going to be able to identify the current value and possibly old values, or when those values changed. Now let me give you a very short example. Let me get out of PowerPoint for one moment. And I'm going to draw here on the board. And let's take, for example, let's take that employee table. So this is the employee. And let's say that we have first name. And then for intended purposes, we're worried about the title. Okay. What we're going to do is we're going to create a record that will give us an idea. Let's just say that we have Tony, and currently his title is going to be, let's just say, Manager 1. And this starts, so we're going to have a start date. We'll just say January of 2020. And we'll have a finish date. And we'll leave this blank. Now, when Tony goes up and changes his title, we're going to create a whole new record. We're going to say Tony now is, let's just say he's a Manager 3. And this happened in March of 2021. So what we're going to do in the blank above, we're going to put March 2021, and then we're going to leave this below blank. And what this allows us to do, right, we created a new, we updated this old record and created a new record regarding Tony. Right? So what this does is it tracks the change of when the title went from manager 1 to manager 2. So when we do an analysis dealing with managers, we'll know what title Tony was during certain date ranges, if that matters. So that is one way of tracking a type 2 slowly changing dimension. Okay. Here's another example that comes from a textbook. This one's not so clear, but let's try to explain it some. So in the fact table, we always have a date and a customer key. So we sold something to customer X on a certain day. And that date usually corresponds to the start date or any time thereafter. And it's related to the certain customer. Let's just say over time, we've collected so many customers, and after 2 years, we found that we no longer do business with this same customer. So what we do is we put an end date into our customer database to indicate when that customer no longer is active. So now we can query our database based on a certain range of start date and end date and determine whether they are active or not active within that certain time frame. So in some sense, this is changing the dimension of the customer, and it's really something that happens very rarely. So that's why they call it a slowly changing dimension, and we notate it this way inside of our database. I'll try to provide some more examples in our classroom as we move forward. So there's other variations of the dimensional model. There are cases where you might have multiple fact tables, and really multiple fact tables just share dimension tables in truth. And also you can have a factless fact table where there's no measure, but it just shows that there might be some association between certain dimensions. I only mention this just to bring this up, that these do exist, but we're not going to be tested on this for any great deal. Now, when you start preparing for your dimensional modeling in the future, just know that there's a basic process. You would prepare, you would profile all of your data, you would build your dimensional models, you would develop it and detail it out, and then you would refine that model. And then later you might go around and ask other decision makers in the organization to validate that model as well. And some essential rules: always try to use atomic facts. And this is what we talked about earlier when we talked about grain. Atomic facts is your basic use of or unit of analysis. Try to think of your fact tables as a single process, like sales. What's the sales process? Don't try to combine too many things in one fact table. Always include a date dimension and enforce that consistent grain. And this kind of ties back to the atomic facts. Do not allow any null key values. And that's why we always have primary key, foreign key relationships in our fact tables. Identify our hierarchies and stay true to them best that we can. Decode our dimension tables so they're not too crazy. What we want to do when we decode our dimension tables is make our dimension tables to be easy to read. Now, in some cases, we also want to use surrogate keys. We did not talk about surrogate keys through any of this lecture, but a surrogate key allows us to create a key that might be consistent across our data warehouse, but it might not exist in the original data coming from the transactional data warehouse, or a database, excuse me. And this is what we call a surrogate key because it acts as a surrogate from the source. And this is very helpful when you have situations where you have customer data coming from different sources. So you can create one surrogate key for one customer that might exist in 3 or 4 different databases. Conform dimensions, that means pretty much make them standard as much as you can. So if you're going to use a customer dimension table in one data warehouse, and then you're going to use a customer data table in another, make those identical. That will help you out a lot in the long run. And also balance the requirements with actual data. Make sure that you don't have decision makers creating a wish list of data. All right. With that, I believe that ends our presentation here. And please let me know if you have any additional questions.